going to do is we're going to slow down today and make sure you guys understand how to describe the transformations that are going on in number 4. All right? I want you guys to look at the original graph, which is f of x equals the square root of x, and we're going to compare all of the new graphs based off of this parent function. There are 2 things that are happening in this graph right here. One of the 2 things is dealing with this concept of there is a 3 being added to the x inside of the radical. The other thing that's happening is there's this 1 that's being added on the outside. You're going to have, in your journal, you're going to be having a quiz over what's happening in your graph. You got to be able to look at your journal and know what situation is going on. If you guys look over at your chart behind over here at this table over here, you guys look at this. Which one do you think is going on in this graph when I highlight the x plus 3?
Horizontal translation with 3 units left.
I believe what he said was a horizontal translation, 3 units left. All right? So, what I'd like you guys to do on your paper is put f of x plus a. That's the situation that's going on right here. And that is dealing with a horizontal translation, 3 units left. 3 units left. Now, if you go to the calculator, you can actually check it. In your calculator under y1, if you hit second x squared and you type it in x and you hit the graph button, that's your original graph. If you hit y equals and go to the y2 and hit second x squared and type in x plus 3 and hit graph, you will see that the new graph has been shifted 3 units to the left. I'm going to hit zoom. I'm going to hit zoom number 4 so it looks a little bit easier. You can see the picture a little bit better. All right. So the next part that we're going to look at is what's happening with the 1. And that's specifically dealing with you have a function f of x, but now you're adding a constant at the end. So Shayla, what's happening with this one? What's going to be, what did you put? Okay, vertical translation. Correct, vertical translation. 1 unit up. So there's only 2 things happening in the graph. Students are pretty comfortable with these 2 particular types of translations. Horizontal, definitely vertical. Horizontal sometimes might be confusing whether we go left or we go right. Just remember, on this one, if you wanted to get back to 0, negative 3 plus 3 would get you back to your origin, your 0. Okay? Now, it may look like there's only 1 thing happening in the graph, but there's actually 2 things happening. We have, the first thing that's happening that you were mentioning was this part right here. Specifically, we have f of a negative x value. So instead of f of x, by the way, this right here, this is your original equation, f of x right here. Now we have f of a negative x. And Liz, you're correct, that does specifically state that this reflects across the what? The y-axis. So f of negative x But if I had a negative f of x, that would reflect across the x-axis. So if I wanted to make this change and go across the x-axis, I could change my equation to. So that would actually mirror this one. So we need to know the difference between where the negative is on the outside of the function and where the negative is on the inside of the function. Okay? I need you guys to see the relationship that these equations right here are not equal. One of them reflects across the y-axis, one of them reflects across the x-axis. And the second part right here mimics what we just did, f of x plus a. And yes, this part translates 2 units down. If you put it's a vertical translation 2 units down, that's fine. Once again, this one was relatively easy because there's only 2 things happening. Okay? The hardest part was probably understanding that this reflects across the y-axis. In a graphing calculator, you can see that happening. Okay? And so what we're going to do is we're going to look at this real quick to prove to you that it does indeed happen. We go to the calculator. I'm going to hit y equals. I'm going to go down here, clear this out. I'm going to hit second x squared, type in a negative x. And then I'm going to hit graph, and you should see that it does reflect across the y-axis. Kind of gives you proof that it indeed happens. And then if I said over here on the outside of the radical, it has to be on the outside of the radical. If I say minus, is it 2? Minus 2, then you'll see it drop down 2 units. The main thing is, look what happens if I don't put it on the outside, but I put it on the inside. You know, it moves somewhere different. Okay? So you got to be careful of, is it on the outside or is it on the inside? All right, now we're going to go to C. My A value, everybody, in this particular case that I'm going to highlight, my A value right here is 0.25, which is the fraction of 1/4. Okay? So the very first thing that's happening is we have f of a times x. And whenever the a value is right there on the inside of a radical sign or a parentheses or a bracket, if it's on the inside, we're dealing with what's known as a horizontal stretch or compression. All right? So it's either going to be a horizontal compression or it's going to be a horizontal stretch, and that all depends on what the a value is. Our a value is less than 1 and greater than 0. And so whenever the a value fits somewhere between the 0 and the 1, if you look at your notes, it lets you know that lets us know we're dealing with a horizontal stretch. Okay? Right here. Right there? Good. All right. By a factor of 1 over a. Now we're not done yet. I'm just putting 1 over a because in our particular case, what is our a value? Our a value is a 0.25. Now, the fast way is understanding that if you have a fraction that's 1/4, 1 over a will simply become the reciprocal of it. So whenever you have a fraction, 1 over a is always the reciprocal of the fraction, and your answer would simply be by a factor of 4. Okay. The second part's the easy part. It's just what? Translated.
40 units down.
That's it. 4 units down. Okay. I'm not even going to do the graph on this one. All right. Technically, once you get good at this, you don't need the graphing calculator to solve the problem. You just have to look at what's happening in the graph and be able to write a sentence. I might give you a huge equation at some point. All right. That has all 6 different transformations. I won't be able to do all 6. So it's either you go left or right. It's going to go up or down. Okay. But you have to write out everything that's happening in words, like what's happening in the graph. Okay. So you need to know